Hello everyone, and welcome to this video where we're going to talk about outboard motors, how to connect them, how to make them work with steering. This comes with great anticipation of the rod fishing update, which is going to come out tomorrow. So if any of you are in the process or want to build a fishing boat, this video is for you. Now this tutorial is going to be an intermediate level tutorial, specifically because I expect that you already know how to make a motor, an engine, connect all your boat, all that stuff. So it's going to be more intermediate, not quite advanced, but just a little microcontroller to control these motors. Now if we watch here, you could see them actually moving, but on this boat specifically it is not a proper system, and what I mean by that is it still does use rudders. For the purpose of this video, I'm calling outboard motors anything that has a external propeller mounted on a pivot. I'm not referring to the motor physically being inside where you'd expect it to be. In the case of this boat, it's actually mounted inside the hull. So we're actually having an inboard motor, but it's like a fake Stormworks outboard motor. Outboard motors do exist in the game. Here you have examples by Mr. NJ. The advantage, of course, is that you don't have to have a huge engine inside your hull, so it's all here, and you could use a small pivot. The disadvantage, in my opinion, is visually, like it doesn't quite look as nice, and also when the engine is inside the hull, I can make it a better engine, put a supercharger, make it a bit more functional. So there is trade-offs and benefits. Here we are on the bottom of the boat where we could see that there are 3 rudders currently, and what they do is they make sure that the boat actually steers properly, and the motors in this case only just help a little bit. But if I go ahead and delete these rudders, you're gonna see what it looks like with a very poor microcontroller. But it's not awful, just not very good. So you steer, it'll turn, except the issue is you turn too much and you start to jump and go crazy. So the issue with powerful engines is you may end up in a situation where your outboard motors do something like this. They're turning too much for the speed. Now this current system actually uses a function microcontroller, whereas we would probably first resort to using a clamp, or someone may think, okay, a clamp is going to be the best bet because of course I clamp my limits, maybe make it between negative 0.4 and positive 0.4, and you just go ahead and attach that to your throttle or to your steering, so your A and D, and we're going to find that up here, A and D, put it onto the clamp, and we're going to attach these two to that. So that is kind of the most basic way, but I don't like clamps in a sense that when you do exceed this clamp number, your steering is still going to go all the way to 1 or -1. It just stops it here. So what you're going to have is a long delay where this goes, when it's 0.5, 0.6, 0.7, 0.8, 9, whatever, it'll just be at 0.4. And then when you release your A or D, it's going to have to count down until it hits this clamped value. At that point, it'll engage. So what I prefer in this very primitive sort of microcontroller is to actually use a function gate, and all I'm going to do is put x multiplied by 0.4. So this way, it's a slower change, so when we're at 1, we're actually hitting 0.4, but the difference is that now we get full range of motion, so it won't have like a dead zone like you get here. So the clamp will get you a dead zone, a function won't. So what you have to do to make up for that is turn up the speed potentially and change the gear ratio. So what I did to all these is reduced the max power, and I just kept the speed as it was. I could have also turned the speed down, and I set it to gear ratio 1. But now right now they're all the same. I'm going to hop in and test out what exactly happens when I move the rudder now. So watch that. So do you see how the left side has a delay, whereas the right side does not have a delay? So if you have to choose one system, I think the function is better, and then you kind of have to fine tune your motor and whatever. But obviously, just without a doubt, if you want to plug in your steering directly into this, this is a big no-no. This is just gonna, in fact, it'll cause your boat to have phantom physics because your motor actually wants to bend the full way. So highly recommend you do not plug in your throttle or your A&D, your steering, directly into these. If you have to, use your function. So don't use this threshold or clamp, but use the function. However, I did come up with a better system, and you could actually see it in action here on my boat, my new one, the Reba. And this one still does have the rudder, but if we delete the rudder, you'll see that it still is much more stable than what we saw in that other boat just now. So you see how we have a big range of motion, and then as we gain speed, it no longer gives us a big range of motion. So the downside of this system is it does take a little bit to turn, meaning it's not an instantaneous turn as you would expect with a rudder. But I'm going to press D now, and then you see it's turning. So it still is pretty fast here. It's just not, like I said, that kind of instantaneous that we'd expect from the rudder. But you see that we're not flying. I mean, this is a pretty powerful boat, so we are getting some motion out of the water, and then our actual motor cuts out because we do have a sensor for that, but it's not letting us turn like crazy at a high speed. So how do we make this microcontroller? Before I begin, disclaimer, Stormworks. This game has hundreds of possibilities, hundreds of different ways to do different things. I'm not claiming this is the best way. There may be more advanced, better ways that use more sensors. This is just better than using a function with multiplying it by 0.4. So I'm not claiming that this is the best. There must be better microcontrollers out there. But if you're struggling with having these work and you're kind of finding it's flipping all over the place, we can use this method. So I did turn my speed up, I kept my power, and I left my gear ratio. Now what I could have done is dropped the gear ratio and maybe left the power. The point is, you have to tune this. I would stick with some variables, so you don't want to play with all of them at once. Then we have our empty microcontroller, and we're going to start adding things to it. We hop in, and it is actually a very simple microcontroller. It only has 3 nodes. One is, of course, your number output, which is going to go to your pivots. Then we have a number input, and we have another number input. One is your speed sensor, and the other one is going to be your steering. So with these in place, this is all this controller really needs. Now again, there must be better ways that uses other sensors potentially, but for this one, we're just going to stick with these 3. And it's actually not a very difficult microcontroller, but pretty much what you'll want to do is have a function that goes into your that goes to these 2. Then you'll want to connect all of the things to this function. So it's a very simple microcontroller consisting only of this, but what it is and what it's going to do is it's going to use the steering and the speed to get you a value for your pivots. So what I tried and kind of found that worked quite well here. We'll start with a simple equation here, which is x divided by y, or steering divided by speed. So steering is anywhere in the range of -1 to 1. So it's coming from your seat. And then speed is your meters per second speed. Now, the way that meters per second work, or the game units, is it's roughly half the knot value. So 10 knots is roughly 5 meters per second. So pretty much what this equation gives us, if you do the math, is that when you're steering at, for example, a full 1, say you put 1, right? You're steering 1, so it's 1 divided by 5. And what that gets us is 0.2. So the higher the speed, the less you are going to have going to your pivots. So this is a basic starting point here, but we could take it even further. But I'll show you first what happens. So I connected the steering, I connected the speed to the speed sensor up here, and I connected these pivots to the pivots. And if we go ahead and spawn it, you may be able to guess what's going to happen here, but pretty much you're going to turn this and you glitch out, because at a stopped speed, your microcontroller allows a full motion all the way to 1. So that cannot happen. So we need to put a clamp still, and we're going to put our clamp to be negative 0.3 and positive, let's call it 0.3. So in this case now, it will have limited us to these values, and if we spawn it in and go take a quick look, you'll see that it does that and does not really destroy the ship. So that is a first starting point, that you have that. Now I did limit it to 0.3 because if I put it to 0.4 it will ultimately glitch and cause the phantom physics. So this is a okay microcontroller, except for one thing. I believe that the speed here, especially for this boat, is too high, and this amount of microcontroller, like what we have right now, will cause the ship still to flip. We'll start with a field test though. So with this method and no rudder, if we go to steer, you actually get it steering almost too aggressively. So for this boat, this is too much steering, and you actually end up, and look at also they're glitching out right now. So not only that, but there is something that has to be done. And what it's going to come in the form of is an adjustment here in this microcontroller. So what we're going to do in addition to all this is actually add a factor for our Y. So our speed will determine what happens to this microcontroller. So I always like to run the math. So what I do is, if we're steering at a full 1, so 1, and then we have a speed of 5 knots, or sorry, of 10 knots, or 5 meters per second, it'll be 0.02, as in our example. But what if we put a multiplying factor? So what if I say here, y multiplied by 0.05? So in this case, now our y changes. So it goes from being 5 meters per second to being 7.5. So in the case of 1 divided by 7.5, we get 1.33. So it actually reduces it a little bit. Now you could put it in here, but what I recommend is you put it as the z variable and then go here and add it as a number slider or a property number. Property number is honestly fine. And what you'll do is have this be reducing factor, and we'll put 1.5. Now you'll have to remember, if you do it this way, you'll have to remember, so maybe it is better to put it on a property slider. That way you can have it to your own kind of advantage. If you have it go up in 0.5 intervals or in 0.25, I don't know if the game allows 0.25, but regardless, you can have, and that would also be rounding. So you'll have it maybe go all the way up to like 3 and down all the way to maybe -1. And with this case here, now we'll see if this works. It does work, okay. So here you can actually have it as such. So we'll put it at and it doesn't show the 0.25, it just shows it as 0.8, but that's fine. So in this case, we don't need the other reducing factor. You can go ahead and remove that and only keep this one. But we have it here as z, and here we have the z variable, which is our 1.5. Now if we go ahead and spawn this in, you will notice that it can steer very fast at lower speeds. So when you're in the marina and whatever, it will allow you a good amount of steering. But as you speed up, it will drop that steering drastically. So you'll see here, that's all that we're getting for the pivot. However, it's giving us a wide range of motion. So you can actually steer quite well. Now I do recommend that this configuration be adjusted depending on the boat and depending on the speed. So for this little boat and these two motors and this engine power, this factor is enough. And so we could actually kind of avoid the cliff face. So it gives us a decent steering, but I still think that having a rudder is advantageous, which is why I put it in the final version of my creation. But here we are weaving between these. So even with that, these two propellers on these two pivots so outboard motors, seem to work quite well. So thank you all for watching, hopefully learned something. If you do have a better system, please let me know. However, I'm probably not going to implement it. For me personally, this is good enough. I know when to say something is good enough for my boats, so this is good enough for me. But for those of you interested, maybe it is worthwhile to scroll through the comments and see what other people come up with and what other type of microcontrollers can be beneficial for an outboard motor. So thank you all for watching. Stay tuned for more videos, especially for the fishing update. Stay tuned for more creations. I got a bunch coming. And as always, happy Stormworksing, everyone.